Hello everyone. In this lecture we are going to talk about functions. Now there are lots of functions in Excel. The functions I'm going to talk about are mostly math and engineering functions. Okay, when we get to arrays and matrices, I'll talk about the functions for arrays and matrices. Some of them are also for statistics. And there are functions for logics, for data lookup, and so on, for strings. So whenever we get to any of those sections, we're going to talk about them. But right now, what we want to focus on is math and engineering functions, and the basic functions that you see in many programming software like MATLAB, in many calculators, and so on. So if you want to, of course, addition and subtraction, multiplication and division, there is no big deal, right? Everybody knows we use plus, minus, and then we use asterisk, and then we use forward slash. But when you want to raise a number to another number's power, so one way is, of course, using caret. The other way is using the built-in function power. So when you say power, 2 and 3 means 2 to the power 3. In Excel, we have natural log, it's ln function, and we have log function. Log function can be a x or any number to any base. So there is no limitation on what you want to put to that base. Okay, you can put whatever you want in that base. Okay, so that's about log and natural log. You have the exponential function, e, right, the Euler number, which is this guy here, raised to this power. So here is e to the power 1. So this is your Euler number here, 2.718. We have sine function, cosine function, tangent, and cotangent. So we have cosine, we have tangent, we have cotangent, we have secant and cosecant functions. We have all of them. I'm just here showing you sine as one example. And the important thing is for the sine, cosine, tangent, and cotangent, the input is in radians. So if you go here and say, what is sine of 30? Do not expect it to give you half. It's not going to do that. That 30 is 30 radians, okay? And when you want to enter that angle in degrees really, there are two approaches. Here, like MATLAB, you don't have a separate function like sine d. So you have to convert that x from degrees that you know to radians that the sine function will accept. So there are two ways to convert your degrees into radians. Either directly you convert it by using pi, and for the value of pi, you don't need to type 3.141592, so on and so forth. MATLAB has a function that returns the exact value of pi, just like the keyword pi in MATLAB. So here, all you need to say is say pi. And this function, you need to pass to it an empty parenthesis. So if you just simply say pi, it is not going to know what you're talking about. You have to pass to it empty parentheses, then it will return the pi number to you, okay? And I mentioned that here at the end of this list, that if you want pi, all you need is to type the function pi. Another way, so now if you want like sine of 30 degrees is what? Pi over 6, right? So you say sine of, and then you say pi, and then you say over 6, and now you get a half. Okay, you see that? So that's one way. The other way is no, you convert your degree into radian by this built-in function, which basically does the same job. But the function is called radians, so you pass to it the angle in degrees, it converts it into radians, and now, if you want, you can use that as the argument for another function, right? So now I can say, hey, this is equal to sine of radians of 30. So convert your 30 degrees to radians, then give me sine of that. right? So you see that these are two different ways to get the sine, cosine, or anything of an angle in degrees. By the way, since I mentioned these two, let me mention this one as well, that there is a function that converts the radians into degrees, okay? So if you say, and the function name, as you can see, is called degrees. So if you say, what is degrees of pi over 6? Then it says, well, of course, it's 30 degrees. Okay, so just wanted to know that you can convert from each one to the other one. Okay, so I mentioned these three guys and I mentioned these guys. What else? Well, you have the inverse harmonic functions, arcsine, arccosine, arctangent, arcsecond, and so on and so forth, okay? So you have all of these functions as well. You see them, it is even suggesting those to you, right? And it returns, again, the angle it returns is in radians. So here I said, what is a sine of 1? The answer is pi over 2, and that number is pi over 2. So it's not going to give you 90. Okay, if you want, you have to use the function degrees and convert this into degrees. The same thing happens for the rest of them, a sine, a cosine. We also have the hyperbolic functions, sine hyperbolic. We also, of course, have the cosine hyperbolic. We have the tangent hyperbolic and cotangent second and cosecant hyperbolic, okay? So we have all of these guys as well, which, as you know, these are not real harmonic functions. These are really exponential functions, but hopefully you have seen them in your math. If for any reason you haven't, please watch one of my other videos where I talked about it. But I want to tell you, for example, let me do that very fast here. So sine hyperbolic of x is equal to exponential of x minus exponential of negative x divided by 2. Okay, and similarly, if you want the cosine hyperbolic, so cosine hyperbolic of x is also, just to make sure this is an equation here. Cosine hyperbolic of x is also equal to e to the positive x plus e to the negative x divided by 2. And then, of course, tangent hyperbolic is the ratio of sine and cosine, and so on and so forth, right? So the definition of these guys is rather clear, and let me add them somewhere down here for you. So you have these definitions. Okay, so then we have one arctangent that takes 2 inputs instead of 1, and that's the exact same thing that MATLAB does. And it takes the x and y, or the cosine and the sine of the angle, and returns to what we call a quadrant corrected angle. Because you know, this arctangent will receive the ratio of y over x, or sine over cosine. So if the sine is positive 1, cosine is negative 1, cosine is like 0, or the other way around, or let's say if the sine is 1 over square root 2, cosine is positive 1 over square root 2, or the other way around, sine is positive, cosine is negative, the answer of arctangent is going to be the same because the ratio is the same. But you know, the answer of really those for those two sines and cosines are two different angles, right? One of them is 135 and the other one is negative 45 degrees, right? Or you can say 315 degrees. So they are not quadrant corrected. Arctangent 2 is quadrant corrected because it looks at the sine of both x and y component, or sine and cosine. The difference is here it takes x and y. In MATLAB it takes y and x. So the order is different, but you have the same function. Of course, you have the absolute value function. You have the sign function. You know, sign returns a 1 for positive numbers, -1 for negative numbers, and 0 for 0. You have the square root function. You have the factorial function, and the function is called fact. Okay, so fact, squared, sine, ABS, and so on. You have the quotient and modulus of divisions, right? So modulus of division of 8 and 3, when you divide 8 by 3, the remainder of that division is 2. And when you divide 9 by 2, the quotient of that division is 4. Okay, so you have the quotient function and you have the mode function. Then for converting decimals into integers, there are 4 functions. You have the round function, which works based on whether your decimal is more than 0.5 or less than 0.5. Right? So it does matter whether it's 3.6 or 3.4, the result of round is different. Truncate doesn't care what your decimal is. It just throws away the decimal. So we have round, truncate, and we also have ceiling and floor. Ceiling is always the bigger integer, the integer that is bigger than your number. So although 2.3 is between 2 and 3 and is closer to 2, but ceiling means select the next number. So it's going to be 3. And if you pass it to floor, floor is always the smaller integer, so it's going to be 2. Okay, so floor and ceiling are always in one direction, ceiling toward the bigger number, floor toward the smaller number. Round, look, see whether the decimal is bigger than 0.5 or less than 0.5, is close to which one of them. Truncate doesn't care, it just throws away the decimal. Okay. Then we have combination of k objects out of n objects, which I assume you know the formula for it, p of n and k. If you don't, I'm going to add it for you here, but hopefully you know it. But just to make sure, I will do that for you. So p of n and k is equal to n factorial divided by k factorial times n minus k factorial. Okay, these are the different combinations without caring about the order of k objects out of n objects. Okay, so just in case you didn't know it, then so let me mark that. So we have all of these functions. We have a bunch of functions for complex numbers. I'll get into those, but there are some other functions. Let me talk about them first, then at the end I'll go toward complex numbers. So yes, you can deal with complex numbers in Excel if you want. Of course, it's not as simple as MATLAB, but yes, you can do it. So we have random numbers. Can I generate random numbers? Sure. The command, very similar to MATLAB, is called rand. And when you say rand and don't pass any argument to it, just pass it with empty parentheses, the number is between 0 and 1. It's interesting that anytime you refresh this, so here I generated the number, right, the random number. Anytime you change anything and the Excel sheet is refreshed, this number is going to change, okay? So that's the interesting part, that, look, here I'm using F9 to execute the whole Excel file and apply all of the formulas. Every time I click on F9, these two random numbers are going to change. Now, what's the difference between these two? This one is random without any input, so it's between 0 and 1. This one is called rand between. And this is going to be an integer number between two numbers, A and B. Okay, so the top one is a decimal between 0 to 1. This is an integer between two numbers of your choice. So we have two random commands in Excel. There is more, but these are the two main ones, rand and rand between. Okay, so these are some nice commands that I like. Then if you are into computer, and memory and different formats for numbers. You want to convert decimals into binaries or binaries into hexadecimals and so on. Excel has a bunch of converters. So for example, you want to know number 11. When you convert it to number 1011, I'm sorry, number 1011 in binary corresponds to what number in decimal, right? So, and that is number 11, right? Because if you divide 11 by 2, subsequent divisions, the result is going to be 1011. Or if you put the powers of 2 above these numbers and multiply, so this is 1, this is 2, this is 4, this is 8. It's going to be 8 plus 2 plus 1, which is, of course, 11. Or the other way around, if you want to convert your decimal into binary. For example, what is 15 to the base of 2? Well, the number is 1111, okay? So if you want to convert decimal into binary or the other way, and you also have converters for hexadecimals and oct to the base of 8. Okay, so you have these guys as well. We have functions for showing date or date and time, which I like quite. So here is this function called today. You don't need to pass to it anything, just use it with empty bracket, empty parentheses, and it gives you the date of today. Now the interesting thing for this is when you come here tomorrow and open this Excel file so it gets refreshed, it is going to change to tomorrow's date. So it is going to keep updated. It is going to be updated, right? So today is 13 as you can see, but if I open it tomorrow, it's going to be 14. Okay, so this today is a nice one. The other one is called now. Now not only gives you the day, it also gives you what? It also gives you the hour and the minutes. And again, this will be updated. So right now you see it's 1542 or 342. Now if I come back 2 minutes from now, this guy is going to be 1544. Okay, so these functions, just like the random function, will get updated. You see? Right now, look, it's 343. That one is not updated yet, but look here. Let's do F9. There we go. You see? So it is updated. There are two other things for greatest common divisor and largest common multiplier, which are GCD and LCM, right? So what number can you divide 36 and 24 by? They are divisible by that number, and that number is the largest. Of course, that's 12. And which number can you divide by 36 and 24? And that's the smallest number you can do. That's 72, which of course is the product of the two numbers divided by GCD. Okay, so you have LCM and GCD functions. These are also good. Now, one of my very, very favorite functions in Excel, which I really love, and I bet you would love it too, especially if you have to deal with different units, system units, especially like SI units and the British system, and you forgot how much is 1 foot in meters or how much is 1 pound mass in kilogram or grams or something. The best function that I love so far, is my favorite in Excel, is this function convert. I really love this function. So you just say how much is 1, and then you say your selection, 1 foot into what? 1 meters. And those units, they have to be in double quotation marks. So how much is 1 foot into meters? It is 0.3048 of meters. Let me do another one because, again, I really love this one. So convert for me, and you don't have to say 1, but here, convert for me 1 pound mass into grams, right? 1 pound mass is 453.59 grams. Okay, and so it has lots of different units for different systems, and you can see them here, right? You can scroll down between them, and find the one that is your interest. Okay? It can do a lot. Length, mass, velocity, area, energy, power, temperature, and so on and so forth, right? So it is very nice, like how much is 1 calorie into joules, correct? Or was it here? And you see 1 calorie is 4.18 joules. Okay, so this command is so far my favorite. I really like this command. It's very useful, I bet. Okay, now we have seen these. Let's go back to complex numbers. Can we do complex numbers? Oh, for sure. If I want to create a complex number, the command to create it is called complex. And what you pass to it is the real portion of it and the imaginary portion of it. You can clearly see the syntax for it. So when you say, what is the complex of 2 and 3, the result is 2 plus 3i, where I is the base of the complex numbers, right? So the command complex can create a complex numbers for you. But if you simply say, this cell equals 4 plus 7 times I, right? If you do that, Excel is not going to like it. So Excel does not recognize I as an independent entity, as a reserved keyword when you type it. When you use the complex command, then it knows this 3 has to be multiplied by I, and Excel recognizes its own I. But if you type it and assume that, hey, Excel, you know what I is, right? No, it doesn't. You see, it's not going to like it. Okay, so make sure you use the command complex and do not type the value of the complex number like you do in MATLAB. It's not going to work here. Now you have created this complex number. You can get the magnitude of it using the ABS. So pay attention. The command ABS that we used for real numbers to give us the absolute value, where was it? Here. You cannot apply it to a complex number. Okay, in MATLAB you do. You apply ABS to both of them. In here you can't. The command for complex number magnitude is called ABS, imaginary magnitude, absolute value. And to find the angle of it in radians, which is arctangent of imaginary part over real part, the command is called argument. Okay, so these complex number commands, they all have this im imaginary at the beginning of them. For example, if you want the real part of a complex number, the command to use is called, or the imaginary part of it, it's called imaginary or real. Well, it seems like these two are switched. Okay, so if you want the imaginary part, or if you want the real part, the imaginary part of a complex number, like this complex number here, the imaginary part of it, you directly type in the command imaginary. What is the imaginary of this number? And it says that's 6. Then you say, for example, what is the real? What is the real part of this complex number y3, which is this guy here? And it says it's -10. So the command complex, I am ABS, I am argument, I am real, and imaginary. These are the basic for complex numbers. Okay? You also have the conjugate command. If you want to apply conjugate to a complex number, the command, of course, is called conjugate, which basically will negate the imaginary part, right? Everybody, I assume, knows what the complex conjugate is, right? If not, please watch my video on complex numbers. So here, I told you how to do basics of complex numbers. But now here comes the more interesting part. What if you want to add, subtract, multiply, and divide, or raise a complex number to a power? Can you do that? Sure, but again, If you want to add two complex numbers, you cannot simply use the command add. Okay, so here I have tried to do something like that. I've tried to add T2, which is this number, to W2, which is this number. So I've tried to add 2 plus 3i to 2 minus 3i, add the two complex conjugates, and the result should be 4, of course, but you see here, it does not like it. Okay, because this addition that you did here, this addition only works on real numbers. It does not work on complex numbers. Okay? A similar thing for multiplication. If I want to multiply, I cannot say this cell is equal to this complex number times this complex number. You cannot do that. Okay, so addition, subtraction, division, and multiplication with these commands that we use for real numbers, you cannot do for complex numbers. So how would you do it? Again, there should be standard functions for those. So if you want to multiply two complex numbers, the command to use is called IM product. When you do IM product, now he understands that, hey, let me do T2 and Y2 here. We're going to multiply 2 plus 3i times 4 plus 6i, and the result should, of course, be what? Negative 10 plus 24i. Or even if you want to multiply an integer number, or not integer, just a real number. If you want to multiply a real number, like number 2, by a complex number like T2 here, you cannot again use, say, hey, this is equal to 2 times this number. You cannot do that. So even if one of them is still real, it cannot do it. Both of them have to be real. If one of them is complex, those regular operators are not going to work. So even if you want to multiply a real number by a complex, you still have to use the command IM product. Okay? But for that real number that you are using, can you type it? Sure. Right? If instead of this 2, could you say 2 plus like 5i? Could you do that? So one of them you read from a cell, but the other one you type yourself. What do you think? Do you think you will get anything? Of course not. Why? Because remember, I told you Excel does not like it when you go and type I. You have to create that I using the command complex. If you don't create I that way, Excel doesn't recognize it. But 2 has no I in it, so it will accept it from you. But if you type the complex number, even this IM product is not going to work. Okay, so IM product for multiplying two complex numbers. Similarly, if you want to divide, the command is called IM div. You have to divide two complex number, you do IM div. Okay, so now let's go back to this last one. If I want to add two things together, what do I do? Well, you might say, well, this didn't work. Maybe I have, because remember, it was IM product and IM div. So is there a command like IM add or IM subtract? So you type in IM add and nothing shows up. IM subtract. You see here, it says returns the difference of the two complex numbers. That's interesting, right? I can subtract two complex numbers, correct? So I can subtract, for example, this number and this number. So if I want, I can subtract two complex numbers. So complex subtraction can be done. No worries, right? I can do complex subtraction using command what? IM sub, correct? It was doable. What about this complex addition? It seems like there was no command. Did you see any? I didn't. So let me move this to this side. Seems like this is not happy. There we go. And by the way, you can always fix the width of all columns, but first let me type that here. Complex addition, right? So what I want to do is to center everything, fix the width of the column so everything goes to the center, and then I go to format and say auto fit column width. Okay, so now everything is in shape. I guess they are not centered, so let me center them. Good. So everything is there except, as I said, complex addition. If I want to add this complex number with that complex number, remember here I have the command im abs. These are the list of imaginary commands. im abs, im imaginary, conjugate, im arguments. Now if you want the cosine of a complex number or something, or exponential of a complex number, you have to use im. So you cannot say what is exponential of this is equal to, let me show you this and then I'll go back to addition. So say this cell is equal to exponential of, and then type in this number. It doesn't like it. So if you want to raise to because exponential you use a lot, right? Especially for the Euler formula. So you have to use im exponential. Now you can use a complex number here. Okay, so please make sure that, as I said, most of these commands, they have what? They have im, not most, all of them. They do have this im in them. And so, let me say complex exponential. Again, the reason is this one is rather used a lot in complex numbers, right? So I would rather talk about it because I know that you'll see it. So this is equal to im exponential of some complex number. There we go. Good. So let's go back to this addition. So we found that im, when we say im, there is a list of commands for imaginary. And if I go down, I can see all sorts of functions applied for complex numbers. Im real, second, sine, subtract, and then I have what? Im sum. So the command is not called im add, it is im sum. And now, yes, I can add this guy and this one. Okay, so it is called im sum. im sub, im product, im division, im exponential, and so on and so forth. Okay, so now hopefully you can see I can do all sorts of things on complex numbers, generate random numbers, do lots of conversions, get the dates, time, do all basic functions, harmonic, hyperbolic, decimal to integer, and a combination, and so on and so forth. There are more functions, but again, these functions are the base. These are the backbone of most of your calculations. So we're gonna stop this video here, and as I said, in the future videos I'm gonna talk about more functions. Okay, thank you so much.